Now that we know what atoms and elements are, we need to take a look at how atoms actually exist in the real world. And to do this, there are three important terms to understand: molecules, mixtures, and compounds. Let's start by comparing molecules and compounds. A molecule is a group of two or more atoms that are held together by chemical bonds. For example, the oxygen floating in the air around us exists as pairs of atoms that are bonded together. So each of these would be classed as a molecule. Now, even though these oxygen molecules consist of just one element, molecules can contain multiple different elements. For example, in water molecules, one atom of oxygen is bonded to two atoms of hydrogen. Other molecules include nitrogen, chlorine, and carbon dioxide. But something like helium, which exists as a single atom, wouldn't count as a molecule. Because remember, molecules need two or more atoms. Compounds, meanwhile, are substances that contain two or more different elements. And again, the atoms are held together by chemical bonds. So if we look at our molecules, a lot of these will also be compounds, because they contain two or more different elements. For example, water would be a compound, because it contains the elements hydrogen and oxygen. And carbon dioxide would be a compound, because it contains the elements oxygen and carbon. However, molecules like oxygen, chlorine, and nitrogen aren't compounds, because they only contain one type of element. Another key feature of compounds is that the elements involved are always found in the same proportions. For example, water always has two hydrogen atoms and one oxygen atom. This allows us to write formulas for them, using their chemical symbols and the numbers of each atom. So the formula for water would be H2O, with the 2 written in subscript, which means it's smaller and slightly lower down. And this signifies that there are two hydrogens in the molecule. Whereas if there was only one atom of that element, like with oxygen, then we wouldn't write any number in subscript. So carbon dioxide is CO2, because there are two oxygen atoms, but only one carbon atom. A more complicated example is H2SO4. And if you're ever not sure what any of the symbols mean, remember you can just look them up on the periodic table, because it will also have their full name. If we read it letter by letter, we can see that each molecule of sulfuric acid contains two hydrogen atoms, one sulfur, and four oxygens. Although you wouldn't be expected to know that they fit together like this, we're just doing it to show you how it works. Sometimes you might also see brackets in formulas, such as in calcium hydroxide. Just like in maths, the brackets effectively group together everything inside them. And then the number on the outside of the brackets tells us how many of those groups there'll be. So in this case, there's one calcium atom and two groups of OH. The compounds we've seen so far have all been relatively small, containing just a few atoms. Some compounds, though, can contain millions or billions of atoms. For example, common table salt is actually a compound called sodium chloride, which has the formula NaCl. From the formula, you might think that it represents little molecules made of one sodium and one chlorine. But sodium chloride actually exists as huge structures, containing millions or billions of atoms. We covered the details in another video, but you can generally tell which compounds will form large substances rather than molecules because the bonds between the atoms are ionic bonds. And because they form such large substances, they don't count as molecules. The formula for these non-molecular compounds, though, is still important. It just acts as more of a ratio. For example, with sodium chloride, we can see that sodium and chloride are in a 1-to-1 ratio. So if a crystal of salt contained 1 billion sodium ions, it would also contain 1 billion chloride ions. Before we finish, I just wanted to quickly mention mixtures, which consist of two or more substances that are not chemically combined together. So if we took a beaker and we put in some oxygen molecules, some sodium chloride, which is a compound, some individual helium atoms, and a molecule of carbon dioxide, this entire thing would be a mixture, because it contains lots of different substances, but importantly, they haven't reacted with each other. So there's no chemical bonds between the individual substances. They've just been physically mixed together. And because of this, we can easily separate them using physical methods, like filtration, crystallization, or distillation, which we cover in other videos.